Yeah, hi everybody, and I'm happy to see some of the faces I always see when I lecture here at AIU. And welcome to today's lecture titled From Manuscript to Publication. If you've joined my previous lectures, we explored how to design strong studies, how to analyze data, and how to evaluate the quality of evidence. And now it's time to discuss kind of the final and arguably most rewarding step, which is communicating that research to the world. And publishing is more than the last box to tick in your research process. It is the moment that your work transitions from being personal knowledge to public knowledge. And until
And
it's
if I
published,
could just
yeah,
add one thing here.
yeah,
On Monday of this week, Paula A had her PhD dissertation, so she is now a doctor. Just so everybody knows that, okay?
yeah, thank you. Yeah. So until a study is published, your study is kind of invisible, so to say. So it hasn't entered the scientific conversation. And today we're going to go step by step through the publication process, from writing the manuscript, structuring each section, choosing the right journal, navigating peer review, and responding to feedback. And by the end, you should feel confident in taking a completed study, maybe your thesis, a project, or any class paper, and turning it into a professional publishable manuscript. So let's continue. Now we begin with the fundamental question: why do we publish at all? And the primary reason is to share discoveries. Science advances when findings are communicated, not when they are locked in a file drawer. When you publish, you allow others to build upon your work, replicate it, or even challenge it. And this is how knowledge evolves through transparency, replication, and open dialogue. Publishing also contributes to your credibility, whether you're an academic, a clinician, or a researcher in industry. Your publication record signals that you can produce, analyze, and communicate evidence. But publication isn't just about career advancement. High quality papers can shape real world decisions, influencing clinical guidelines, healthcare policies, and patient care. For example, systematic reviews on Parkinson's disease management directly inform recommendations for therapy and medication. So, publishing is both a personal milestone and a social responsibility. I can also share a personal example here. Throughout my PhD studies, I published 13 papers, and a lot of them were systematic reviews as well as original research. And I have had people who read my papers email me and ask me some questions about it, and also give me feedback that they are using it to advance their research or even in clinical practice. So recently, I had a doctor who wrote to me about my systematic review, and he said that my findings helped him identify a medication to use for most of his Parkinson's patients who are in the advanced stage of the disease. So I wrote a systematic review about apomorphine pump, so about an infusion, which very well improves motor symptoms in Parkinson's disease. And this doctor said that the paper, so analyzing together all the clinical trials on apomorphine, I was able to draw the conclusion that it does help patients in the advanced stage of Parkinson's. Okay, let's continue. And I like to think of the publication process as a pipeline. First, you conduct the study, and that is the foundation. Then you analyze your data carefully and interpret what it truly means. And then comes, for some, the hardest part, which is writing the actual manuscript. And this is where we will focus on today. So, writing is not a formality, but it's a part of the intellectual process. And many researchers only realize what their findings actually mean once they start writing. And I can say that for me, writing the manuscript can be the hardest part because usually checking journal guidelines, they have a word limit. Some journals, it's about 3,500 words. Some are up to 4,000, but it's sometimes very limiting, especially if you have a lot of findings. So you need to learn how to cut that down, but not leave anything out. So results are just narrative reporting, and then the discussion, you might not go into so many points, but you still try to touch on everything that it's important. So this is why writing for me is the hardest part. And once the manuscript is ready, you submit it to a suitable journal, which can trigger the peer review process if your manuscript fits the journal's scope. The peer review process is where experts evaluate the rigor, originality, and clarity of your work. Usually they send it out to about two peer reviewers, or they'll send out to more, but then they'll wait for two people to accept and to complete the peer review process. So two reviews are usually normal for most of the journals. After one or more rounds of revision, your paper is either then accepted or sometimes rejected, which is perfectly normal and, of course, a part of every researcher's journey. For me, so far, I've had papers get rejected before peer review. So when the editorial board reviews them and decides that my paper doesn't really fit the aim or scope, or that they have too many papers coming in and they cannot publish also my paper. After peer review, I have not had a paper be rejected yet. I've only had major revisions to be made, and eventually the papers would get published. And finally, once published, your work becomes part of the scientific record, discoverable through databases like PubMed, Scopus, or Google Scholar, and open for others to cite, apply, or critique. So here I want to say that not all journals index in PubMed. So for example, you might publish your research in a journal that is not so old or so well known, and they will not be indexing in PubMed. So most likely your article will only be found through Google, which is fine as well. But as you advance your career and the more you publish, you would look for journals that also index in Scopus or in case of like healthcare research in PubMed, because then like there's more likelihood that your paper will be read by more researchers because those are usually the databases that people use when they search for credible research. Further, not all papers are the same. The format of a paper depends on your purpose and your data. You must have heard of the original research article. These are very common, and it's the backbone of scientific communication. It presents new findings, data, and analyses. So, for example, I have a few original research articles. I conducted survey studies on patients with Parkinson's, and I would publish these studies as original research articles because my research was something new and it wasn't just a review of existing literature. So this was actual research that I conducted with my own instrument and eventually, of course, published the findings. Then there are review articles. Probably also heard of that, and maybe you joined my lectures last time where I talked about systematic reviews and meta-analyses. So these summarize and synthesize existing evidence. You have already studied this if you know the systematic reviews, and these papers help define consensus or highlight any research gaps. So if you didn't join my lecture on systematic reviews, I'll just give a quick overview. So for example, if you want to do a systematic review on a specific medication and see how it improves motor symptoms versus placebo, then you will search the whole like database, for example, PubMed, for all clinical trials that have studied the drug. And then you will take the data from all of them and you will review it and possibly conduct statistics on it, which is the meta-analysis part. And then you will draw a conclusion from all of those studies if there is a significant improvement, for example, in motor symptoms from a specific medication for Parkinson's versus placebo, or there isn't. And such reviews are at the top of the evidence pyramid because we're looking at multiple conducted randomized controlled trials, and we are drawing conclusions from that. Short communications are brief reports, maybe a smaller data set or some pilot study or a novel methodological insight that wouldn't require a full-length article. These, however, are less common as well. Then there are case reports or case series, which are very common in medicine. They describe rare or interesting clinical phenomena and often generate hypotheses for future research. These are often conducted by medical doctors, so especially case reports. If they get a patient that presented with an interesting clinical phenomena that they haven't seen before, and if the patient gives consent, then they might write up a case report on that patient. So everything that they observed, that might include also some imaging if they have for that case, and some blood tests, and they would describe what they have observed in this case report and why it is so interesting. And then if multiple cases like that occur, those would be case series. And most likely those would be done by one author. But also what is good about a case report is that one doctor would publish such a case, and then there is another patient that presents with the same symptoms and the same clinical background to another doctor somewhere else. They could research and find this case report and understand that they're not the only ones. And then they could collaborate in a treatment plan for both patients, especially if it's something interesting and new that doesn't respond to current treatment in the medical field. And then there are commentaries or letters to the editor, which allow researchers to critique or expand on previously published work. I have written one letter to the editor, but it was to suggest a change within IT software. So it wasn't about the previously published work, but I'm currently working on another letter or commentary about previously published work to say that, in my opinion, they could include and expand on that rather than have what they've just published. So you basically read an article that somebody else published, and if you think that they're missing something or you want to criticize what they've written, then you can write these letters to the editor or commentaries to the same journal that that article was originally published in. And if the journal thinks that you have valid points, then they will publish this letter or commentary. And each type of scientific paper has its own structure and length requirements. So you always want to match your paper type to your research purpose. So if I conducted a survey study and collected original data, it will obviously not be a review article, but it's going to be an original research article. And another thing to keep in mind is that every type of paper will have different requirements in different journals. So as I already mentioned, the word limit, I have had journals for original articles that take articles up to 4,000 words, but some it's only 3,500 words. And then there's still the referencing style and other things like subsections that you need to look at for different types of papers. Further, we talk about the anatomy of a scientific paper. And this is what I like to call the IMRAD structure, or Introduction, Methods, Results, and Discussion. And it is kind of a universal template for scientific writing. It's not arbitrary, so it mirrors the logic of scientific reasoning. You start with why you did the research, which would be the introduction. So you cover some background information about your topic, which leads to stating your purpose and aim, so why you are doing it. Then you move further into how you did it, which is the materials and methods, or just methods. And you talk about step by step how you conducted this research. If it is a survey, you will talk about how you recruited participants, how you developed the questionnaire, how you dealt with the data, what statistical tests you ran. So anybody who reads your paper afterwards is able to replicate it without asking you extra questions. So it has to be really clear about what you did. Then, of course, what you found, which is the results. And if you remember us talking about interpreting study results, then we often discussed that in the results section, you don't interpret anything. You leave that for the discussion. So you purely state your results. You state what you found in from certain statistical tests that you ran. You state the p-values, and then you reference to any tables that you might have like made for these results. And finally, what all of this means. So what you are interpreting from your results and how that links to the broader literature and maybe even has implications for clinical practice. And of course, also study limitations and future research. All of that goes in the discussion section. Journals standardize this format because it allows readers to find what they need quickly. So clinicians might just look at the results. Statisticians will like to look at the methods, and policymakers will probably look at the discussion section because it has these policy and clinical implications. Also, understanding the structure makes writing less overwhelming. You can approach one section at a time in building blocks. From personal experience, I can say I don't always start with the introduction, no matter how interesting that sounds. Sometimes I start with the methods because I ran the study, I know what I did. So I write up the methods first. And then sometimes I still go into the results and only then I go to the introduction. Because even though I know my purpose and aim, which will be like the last paragraph of the introduction, I prefer to write out the results so I know what background information to cover in the beginning of the introduction. Also, you don't have to be afraid to just write it all up and then go back and like edit the sections. So sometimes you will go down to the discussion, you're going to write it, and you will come up with a new idea that you probably should have mentioned also in the introduction. Um, Writing an effective title. So your title is kind of a handshake of your paper. It's what readers and reviewers see first and what databases will index. A good title should clearly communicate the essence of your study. So the who, the what, and sometimes even how. For example, I would never say a study on Parkinson's disease because that is very vague. I would say knowledge and attitudes toward pharmacological treatment among patients and practitioners with Parkinson's disease. So as you can say, I clearly said the who, so that would be the patients and practitioners. And then I have the what, so it's a study on knowledge and attitudes towards pharmacological treatment. And in this case, I don't have the how, but sometimes you will see that they say that it's a cross-sectional survey study and then you know that it was done via a survey. You should avoid unnecessary words or any jargon in a title, and don't use abbreviations unless they are universal, such as DNA or AI. You should also think about searchability. What terms would somebody type into a database, such as PubMed, to find your study? And then you should use those terms in the title. So for me, I always put in Parkinson's disease because I know that clinicians will be looking for that. Yeah, I mention all the keywords such as the pharmacological treatment because I'm talking about medications. And for example, in this case, also knowledge and attitudes. And a strong title can significantly increase your paper as a visibility. And of course, then also citations when other people use it in their research. The abstract is kind of your paper's ambassador, how I like to call it, because for most readers, it is all that they will ever read, no matter how disappointing that may sound. But with the abstract, you should keep it short but comprehensive and include a brief context, the aim, the methods, key results, and a very concise conclusion. So it should kind of be a summary of your whole paper in usually 250 words. You should use plain and direct language, and every word must earn its place. So you shouldn't be wasting too many words. So it should be as concise as possible. And most journals will use structured abstracts with subheadings. So you will have a subheading for background, which just states rationale or problem. Then you have the methods, which will just briefly state the study design, the participants, tools, and analysis. Then the results, so only the main quantitative findings, and the conclusion, which is implications or main takeaway in 1 to 2 sentences. About the abstract, one more thing. I usually write it after I've written the whole paper, because for me, it's just easier to summarize the whole paper after I've written the whole thing and only then write the abstract. So it doesn't make sense to write the abstract in the middle of writing the paper or at the beginning because you will have no idea what goes in there until you have written up all your results from your statistical analyses. Also, you shouldn't introduce any new information that is not found in the paper itself. And the abstract doesn't contain any references because again, it's just a summary, and the references will be afterwards in your actual paper. And then if somebody sees a statement in the abstract, they will search for the same statement somewhere in your paper, most likely in the introduction or something. And when written well, the abstract alone should make sense even to somebody who hasn't read the rest of your article. And this again is important because, as I said, most of the time people will read just the abstract. Sometimes they will read just the abstract and they will already find the information they want to cite in their article. And only in rare cases when they really are interested in your research or they need it for their own, then they will go to the specific section they're interested in, for example, the results or methods. But I have done it multiple times myself where I just read the abstract and then I realize if there's anything I need, I use it. If there isn't, then I try to find another paper for my research. And now we come to the introduction, which is like the opening of a movie. I usually like to compare it to that because it sets the scene and convinces the reader to keep reading or, yeah, going through your paper. So you should start with the context and what is known about the topic and why it is important. And then you move to the gap, so what is not yet known or understood. And then you can introduce your specific objective or hypothesis. So you're kind of building on a framework. You go from this is what is known, and then this is what is not known, and then this is what I'm going to do to, let's say, fill the gap and figure out what we don't know yet. You should keep it concise, so about usually 3 to 5 paragraphs for most papers, and avoid turning it into a mini literature review. So the goal is not the goal is the focus and not the volume of the introduction. And your last sentence should usually be crystal clear. It should say, therefore, this study aimed to examine, and then you state your purpose or aim of your study. And that sentence, the last one about the aim, it will tell the reviewer that this paper has a clear direction and purpose. If you forget to state your purpose in the introduction, most of the papers will come back to you to be revised to state that clearly before you go into your results and any of your findings. So it doesn't make sense to forget that part in the introduction. Then we, of course, have the method section, and this is where your scientific credibility is established. You should begin by stating the study design, whether it's cross-sectional, cohort, randomized trial, qualitative, or maybe even mixed methods. Then you should describe your participants, the inclusion and exclusion criteria of them, sample size, and any recruitment strategy which you followed. Then you should specify the tools that you used. We have talked before in our survey research classes about validated instruments, which are the best to use in survey research, for example. So you would state that you used, I don't know, the SDMQ9 questionnaire or PHQ9. They're usually shortened to those names. And of course, you should cite them. Then you clearly outline your data analysis, so which statistical tests you used, which software you used, and why they were appropriate. And you should not forget the ethics approval. So you should include the committee's name, the approval code, and a statement that participants gave informed consent. So all my survey studies would be approved by the Institutional Review Board of the University of Jamestown. So I would clearly say that it was approved by that board. And I would say the IRB number is, and then state the number. And of course, the fact that the participants always gave informed consent in the form of an online informed consent form before completing the survey. And transparency here allows replication and ensures that your work meets international research standards. Without stating the ethics approval and without having the ethics approval, your study will not be published. Because if you are conducting, let's say, the survey research or any type of case study or randomized controlled trial, you're supposed to have approval from the human participant for it to be ethical. And if you're not going to have that, then you were not supposed to be doing the experiment or the study, and then it also will not be published. And results should tell a clear and factual story. Again, we've touched on this in a previous class, but I just want to make that clear again that you should begin with participant demographics and then move to your primary outcomes, followed by any secondary findings. And this should all be just in a very clear stated way that these are the results without any interpretations. You should use tables for detailed data and figures for any visual trends that you want to show, but you should also avoid duplication. If it's in a table, then summarize it in text rather than repeating any numbers again in the text. So you shouldn't put all the numbers that you have in the table again in the text. Usually the table is meant for saving the word count for your article. So try to just put it in words then or examples of a few significant findings from that table into the text and then just reference the table. Say, for example, see table 1. And again, like I said, don't interpret the meaning here and save that all for the discussion. So simply describe what you found. And I could say just, for example, a sentence, patients in group A showed higher adherence rates compared to group B with a p-value of 0.02. So that's how your results are supposed to look. So you shouldn't be adding still meaning, this and this. So the meaning part and what you interpreted from it should all be left for the discussion. So in the end, this section should be very objective, precise, and of course also concise. And now we come to writing the discussion, which transforms this raw data into actual meaning. And here you usually start with a short summary of your main findings, which is just 1 or 2 sentences. So you don't restate your whole results again, but you just write like 1 or 2 sentences of the main results that you found and that you typed up in the results section. Then you continue with interpreting them in context. So how do your results compare with other studies? And this is where you have a chance to expand. For example, I do clinical research in Parkinson's disease, and this is where I usually look at my results compared to any other studies, even in different fields. So not in Parkinson's disease, but I look, for example, in other chronic conditions. I could look at other rare diseases, oncology trials, and oncology studies. So I would try to compare them even outside of the context of Parkinson's disease. Also, you talk about if they are consistent findings or do they challenge existing theories. And here again, it doesn't just have to be your area. Sometimes in my area, there would be no studies that would be looking at this, but there would be that in oncology. And then I state if they are consistent or maybe they are opposite. And I try to form my discussion around that. Also, you should offer possible explanations for differences. For example, were there differences in population, measurement tools, or sample size? So if I found that shared decision making in Parkinson's, that patients rate themselves as less involved than their providers, whereas in another disease it was opposite, the patients felt more involved than the providers, then I have to look at what could be the possible explanations for these differences. So maybe it is the condition itself that maybe people with Parkinson's don't feel so confident in their treatment decisions. Maybe they are less educated about their disease, or maybe it's just the sample size. Maybe the other study studied a much bigger sample and I had a smaller sample, and that could have influenced the findings. Also, you should discuss implications. So, how might your results inform future research, clinical practice, or even policy? So, anything that you can come up with that you could say would improve the care if you're looking at clinical research for future patients, or if you're doing any other research, how could policy, for example, be improved in maybe education studies for schools or for higher education? Then that is your chance to discuss it in the discussion. Also, you should acknowledge any limitations transparently. As we know, there's no study that is perfect, and reviewers really appreciate honesty more than overconfidence. So you should clearly state if there was a survey study, that there was some self-reporting bias, anything else that could have influenced the study, that there were confounding factors, maybe sample size might have been small, or there was an overrepresentation of a certain ethnicity or a certain gender, which might limit the generalizability of the findings. And finally, you should end your discussion with a small conclusion, which is often known as like a take-home message, which reminds the reader why your study truly matters. And a conclusion is usually not long. For me, it's most of the time 1 or maximum 2 paragraphs. Selecting a journal is both strategic and ethical. You should start by identifying journals that publish work similar to yours. And you can check their recent published issues, published articles, or you can just use their search engine to search for certain keywords. And further, then you should also consider the audience. So is it going to be clinical, is it methodological, or interdisciplinary? A lot of times you won't aim for the correct journal from the beginning. A lot of journals will reject your paper, not because they think it's a bad paper, but because they think it doesn't fit their aim or scope. I had that once with a journal called Equity Neuroscience. I wanted to publish there a systematic review of a certain medication, and they rejected it like immediately, saying that it just doesn't fit their scope because their scope is to talk about equity in neuroscience and neurological disorders. And mine was just briefly talking about the improvement of symptoms when using a certain drug. So it had nothing to do with equity. And now I submitted another paper to that same journal, which actually is about equal care of Parkinson's in my home country, Latvia. And it immediately went to peer review because it fit their scope and they liked my paper. So they sent it off to peer review. And also, you might have heard of a thing called the impact factor. A higher impact factor means that the journal has a higher reputation. And a lot of people want a higher impact factor journal immediately. If you're a new researcher, a new author, it's very hard to publish in a high impact factor journal. I will be honest, I have tried, and usually we try, like when we just start publishing, with a lower impact factor. It shouldn't be a predatory journal. It will still be a reputable journal, but it's easier to publish in it than in a very high impact journal where maybe the acceptance rate of articles is 10%. And a focused or reputable journal that reaches your target audience is often more valuable than this top tier journal outside of your field. So it's better to find some maybe smaller, lower impact factor journal that really fits your aim and scope for your paper and publish in that rather than chase the impact factor blindly. Also, you should always read the author guidelines carefully, like I mentioned about the word limit, any format and reference style, and know that the submission procedures vary widely between journals. Unfortunately, this is the most time-consuming part when it comes to publishing the paper, because one journal might accept the 4,000 words and be in the reference style that you originally referenced your paper, for example, APA. But then this journal will reject your paper and you want to resubmit it to another journal that you found where unfortunately the word limit is lower, so 3,500 words. Although we know it's easier to cut words than to afterwards write more. So now you have to cut it down to the 3,500 words. So you have to lose 500 words somewhere. And you have to re-reference all your references because here the journal is using Vancouver style instead of APA. And unfortunately, this is the reality what happens. So you should never delete your original file of your paper. And when you're submitting to a journal, just like make another file and then format it accordingly. Because sometimes for a different submission, it will be easier to just go back to the original one than to again fix the one that you made for the specific journal. And as I already mentioned, the term predatory journals, you should avoid these. These are journals that try to mimic legitimate ones. They usually charge high costs for publication and they skip peer review. So if you see a journal or you get an email from a journal that says we have a high impact factor and rapid publication, those are red flags for predatory journals. And also you can often see like grammatical mistakes on their website. So they would use poor English or they will be promising things like publication within days, when sometimes in a higher impact factor journal or generally just a reputable journal, peer review can take weeks, if not months. So it's normal to wait, and it should be done that way rather than promising publication within days and then your paper never goes through peer review. It just gets published in the form that you wrote it. And if another researcher will read it and see that you published in predatory journal, then your reputation could be damaged through that. So I strongly advise to avoid predatory journals. You can also look online. If you receive any emails from any journals inviting you to publish, you should Google them if they don't already look sketchy, which they do most of the time. But you can also Google, and there is a thing called a Biala's list. And if they are on that list, then you shouldn't be publishing in them. And now we come to the peer review process. So once you submit, your paper will undergo several steps. First, the editor will check whether it fits the journal's scope, as I said, and let's say basic quality. If it will pass, it will be sent to 2 or 3 or even more reviewers who are experts in your topic. If it doesn't pass, there are options that first it gets sent back to you, and there were just issues with the formatting, so it didn't match the journal's requirements. Maybe you missed to read the author guidelines, or maybe something was missing there that they still require, and they will give you clear steps on how to fix it and resubmit it. Or it will just get rejected because it didn't fit the scope, and then you have to look for another journal. If it does proceed to the peer review, reviews can be single blind, double blind, or open, meaning that identities may or may not be disclosed. I have also peer reviewed a few papers, and most of the time they come into me that I don't see who's the author of the paper. It's trying to avoid bias in any way, either if I would know the author or not, there can be bias involved. Or some journals will clearly say that these were the authors. This is a blinded process, so we're not disclosing the authors, and then it will be blinded out, and you as the reviewer will get just a blinded copy. You'll just see the paper without the author's names on it. Usually the side when you are the author, you don't see who reviewed your paper. I think I only had once a review process from a journal that was actually based in Poland. I saw who reviewed my paper, so I saw the reviewer's name. But most of the time, you as the author will not know who reviewed their paper, also to avoid any bias or afterwards maybe criticism. The editor will then summarize the feedback and give a decision. Usually after the review, you have multiple options. So either it's just accepted without revisions, which is, I think it's only in utopia. I mean, I've never had a time where I would suggest acceptance of a paper without any edits, and neither have any of my papers been accepted without edits. There can be minor revision, which is maybe changing a few points, changing very minor things like grammar or some formatting. Then there can be major revision, which will be actually changing like the content of your paper. So maybe you missed something in the results, or you haven't put some tables that they would like to see, or maybe even your introduction has to be rewritten, or in your discussion, they didn't like some of the implications you were making or interpretations. So you will have to revise that majorly. And the last option is reject. So if it comes back from peer review and the peer reviewers have identified that this paper just, no, it won't work for the scientific community, then they might reject it. I think that's very rare to happen, but it will happen if your paper has produced garbage data. If your writing is so bad that nobody understood what you wrote, or it might just be a replication of an existing study, and I think it would just be a waste of space to publish again. You should treat reviewer comments as part of a collaborative process. You should be polite, thank them for their insights when you're responding over the platform, and also respond to each point clearly, even if you disagree. So sometimes the peer review will come back. So it depends on the journal's portal, actually. It might come back as your Word document with comments from the reviewer on specific sentences, or it will just come back as bullet points from the reviewer saying you should be revising this in the results, this in the methodology, this in the discussion. And sometimes you get the chance to just, if you don't want to accept their reviews. So you don't want to implement it in your paper because maybe you think they misunderstood what you were trying to do in your paper. Then you have a chance to just answer and respond to their comment and say, I do not agree with this because, and then you should be really polite and you should still thank them. And then you should say, I disagree because of this. But most of the time, reviewers have really gone into your paper, put their heart into it, and they understand what you meant. So they're trying to actually just give you suggestions to make your paper better. And then you should take those suggestions and you should implement them. Um, yeah, if you can justify your reasoning logically and professionally when you are disagreeing with a comment, or if you are agreeing with it but only partially, then editors will appreciate that. And many accepted papers are those that show careful engagement with reviewer feedback. So again, as I suggest, you should really carefully engage with this reviewer feedback, and even if it's a disagreement, try to put it in a polite and positive way as possible. Common reasons for rejection. So as I said, it happens to everybody, even experienced researchers with dozens of publications. So that's not a reason to get demotivated to publish. I have had papers that didn't get published in 10 journals and got published in the 11th. That is totally fine. And the most frequent reasons can be simple. So either there's a weak rationale, unclear objectives, or a mismatch between the research and the journal's interests. As I said, it might simply just not fit their scope. Sometimes it can be methodological, so they will think that you have an inadequate sample size, missing ethical approval, or poor statistical analysis. And if it is methodological, then you have a bigger issue because you might need to rerun the study before you can publish. So for example, if there wasn't enough sample size, then you have to recruit additional participants and rerun the statistical analysis. Or if there's missing ethical approval, you have to trash it all and you have to go back to the IRB and get an ethics approval. Poor statistical analysis is a little bit easier to solve, so you can just rerun tests. You can, look for the adequate tests and then just redo them in the statistical software. And then there's also stylistic reasons for rejection, such as disorganized writing, grammatical errors, or failing to follow formatting rules. These are, again, things that obviously can be changed and fixed. And the key is not to take any of this personally. You should use reviewer or editor feedback as a roadmap for improvement. Revise your paper carefully and resubmit it then elsewhere. Persistence is part of the academic game. One thing you should know about rejection is if it gets rejected from the journal without them asking you to, for example, review your grammar and resubmit it, if it's actually a rejection, you cannot resubmit it to the same journal again. You have to look for another journal. So they will most of the time also state it in their email very clearly that it got rejected and do not resubmit it to us again because we will not review it the second time. Next, we could talk about open access and copyright. You've probably seen these terms and sometimes you might question what these are. Open access has actually revolutionized publishing. In the traditional model, readers or institutions such as your university may pay subscription fees so you can read the article, or you might need to buy the article yourself if your institution doesn't have a subscription. Whereas in open access, the article is freely available online, but the authors or funders of the authors pay an article processing charge. Sometimes these article processing charges are pretty high, especially in reputable journals. They can be about $3,000, maybe sometimes over that. So you should really either seek funding or you should really determine if you need to publish open access, because most of the time your article will be read by a good audience also without open access because they will have a subscription. However, open access does increase visibility, citation rates, and public engagement. I also like to read open access articles because sometimes my institution does not have, let's say, the license or the subscription to get the article through a certain journal. And you should be aware of any copyright agreements because many journals now use the Creative Commons licenses and they will be abbreviated like CC BY. And they allow you to share your work freely while retaining authorship rights. But you should always check your funders' requirements as well. If you've had a grant for your research, some of them now mandate open access publication. And if you've published not open access, then you won't be able to put this article freely open on things like ResearchGate, because then nobody's going to buy the article. They're just going to find it on ResearchGate and read it for free. And then you will have a copyright problem between you and the journal. So if you publish without open access, then you either have to request the journal if you're allowed to share it with other people, or you just don't share it. You use it for your own, let's say, files and archives, and then whoever wants to read your article will have to purchase it. Ethics don't stop at data collection, but they also extend to publication. So it's important to look at that as well. You should always ensure your writing is original and properly cited, so you don't plagiarize. And journals routinely use plagiarism checking software, so you should paraphrase very meaningfully rather than copying and pasting. You should never manipulate data or images, so scientific misconduct can permanently damage a career. If that will happen and you've already published, they will then realize that you've manipulated data. Your article will get retracted, and then you will have problems further on. You will not be able to publish in reputable journals. It's a really big mess, so you should not be manipulating any data. You should always acknowledge co-authors and contributors accurately. There is a thing called ICMJE authorship criteria. So usually you say these co-authors contributed to these parts of the manuscript. You should also keep your raw data securely stored and available if editors request it for verification. And finally, you should disclose any potential conflicts of interest, such as funding sources, affiliations, or personal ties that might bias interpretation. When revising your manuscript, you should create a point-by-point response table. For each reviewer comment, you can copy it and write your response, and then indicate what changes you made in the manuscript for their comment. As said, you should be concise but respectful, so you should avoid any defensive language, and you shouldn't be saying things like the reviewer is wrong, but instead you should say, we respectfully disagree because, and then you should be providing any evidence why you disagree. You should highlight changes in your revised manuscript so editors can easily track any modifications. I usually highlight them in yellow or any other color, but just highlight them. This process can feel tedious, but it dramatically improves your paper and your relationship with the editorial team. So as said, you should be responding to your reviewers' comments and taking them seriously. And of course, we have promoting your published work. So publication isn't the end. It's actually the beginning of visibility. So you share your paper on professional platforms such as ResearchGate, LinkedIn, or even Twitter, which is, I think, now called X, tagging the journal and any relevant researchers, for example, your co-authors. You present your findings at conferences or webinars if possible. And these interactions often lead to collaborations or future projects. You can also register your paper on ORCID, which is a portal where all your papers eventually show up if you've registered them there, or sometimes the journal will do this for you. They will ask for your ORCID ID, and then it will be there. There's also Google Scholar. If you have made an account there, then Google Scholar will be assigning each article that it finds on the internet with your name on it and ask if that article is yours and if you want to put it in your Google Scholar profile. So I usually get emails regularly of them asking if I want to update my articles on Google Scholar. And the goal isn't self-promotion, but it's knowledge dissemination. So ensuring that the work that you spent months on actually reaches and benefits others. So I always post my research on ResearchGate, and I also share it on LinkedIn with my connections who have similar interests and who want to read my findings. And yeah, now I want to take your questions and in a way also have you reflect on maybe what part of writing or publishing feels most challenging to you and how we should treat non-significant results or what makes your paper truly publishable. So these are things you can discuss with me or ask any questions and I can help you if you have anything. And of course, thank you for joining my lecture.